Okay, we're gonna discuss the concepts of density, mass, and volume. The main ideas of these concepts are that volume is basically the size or the space that is occupied by an object. So depending on the number that you have on volume, if it's a big number, that means that an object has a really big size, because the size basically tells you the space that is occupied. If the number is low, then it means that the size of the object is small and the space that's been occupied is basically short. The mass is basically the amount of matter that is contained in an object. If the number is higher, it means there's a lot of matter. Okay, there's much. If the number is lower, then that means that you have less amount of mass. The density represents how close the molecules or the atoms in the object are one to the other one. The more molecules that are together, the higher the density is going to be. So if you have a lot of molecules together, that means the object might become like a heavier object. And if you have less molecules together, then the object is going to be less heavier, it's going to be lighter. So this is related with grouping of the molecules or the atoms. If the number of density is high, then it means that it's crowded inside. In a molecular level, it's crowded. And if the number of the density is low, then it means it's almost empty. Those are the main ideas of each one of these concepts. Now, some relevant information that we need to know. When we're talking about density, we need to understand that each type of material that exists in the universe has a different density. It's not the same the density of water as the density of iron, as the density of gold, as the density of mercury. Each one of the densities of each material is different. That's why some materials are heavier than others. That's why some materials are lighter than others. It depends on the number of their density. We have some formulas that we can use to calculate what is the density of a specific object. The density of an object is found by dividing the mass of the object with the volume. So these three concepts, as we saw before, are related one with the other one. If you want to find the volume, you just need to divide the mass of the object with the density of the object. And if you want to find the mass, you just multiply the density of the object with the volume of the object. So the symbol that we see here represents density. And the units of density are kilograms per cubic meter. The symbol M represents the mass, and the units are kilogram, and the symbol capital V represents volume, which is measured in cubic meters. Like I said before, each material in this universe has a specific number that represents its density, and they're all different. If they were the same, then it would be the same material, but they're not. So some numbers that might be important or might come in handy when solving exercises are the ones that appear on this table. Mercury, for example, has a density of 13,600 kilograms per cubic meter. Water has a density of 1,000. Alcohol has a density of 790, etc. So this is the information that's going to be relevant when we try to solve exercises. Now, let's try to solve a couple of exercises. For example, exercise number 1 says, what volume does 0.08 kilograms of alcohol occupy? So we know that we're looking for the volume. The exercise is telling us what is the mass, because if you see kilograms, remember that kilograms are the units of mass. So we're talking about M. So M in this exercise is 0.08 kilograms. We also have that the material of the object is alcohol. Okay, we're talking about alcohol. That means the density of the object is 790. If you notice, the type of material gives me the density that I need to use. So in this case, I know that the density is going to be equal to 790 kilograms per cubic meter. Now that I know that, I just need to answer the question, what is the volume? So how do we find volume? We're going to use the formula that we saw before. Volume equals mass divided by density. So I just need to divide mass with density. I just substitute, and the mass in this case is 0.08. divided by the density, that is 790. This kilograms per cubic meter have to keep this way, to be kept this way with a slash. So 0.08 divided by 790, that would give us an answer of 1.0127 times 10 to the power of minus 4 cubic meters. That is the volume. Cubic meters because those are the units for volume. And that's it. We found how much volume is occupied by 0.08 kilograms of alcohol. Number 2. Exercise 2 says, an unknown substance has a volume of 32 cubic meters and a mass of 325 kilograms. How much mass would we have with 120 cubic meters of this material? So this is what we're going to call a two situations exercise. Okay? If you know this, they give me one volume, but at the end of the exercise, they also give me another volume. So it's kind of like confusing, right? We have two volumes. What's going on in here? Simple. We have two different situations. We need to be able to split them. Okay? So in order to split them, we're going to use subindex. The first volume is going to represent the first situation. So the first situation is that we have an unknown substance. We don't know the substance. We don't know the material. But we know that the volume is 32. So I know the volume is 32. Now, what else do I know? I know that the mass of the object, is 325 kilograms. Yes? Now, after that, there's a question. How much mass? So they're asking me to find another mass. So that's the second situation. Okay. Now we're not talking about the first mass. We're talking about another mass. Which new mass we will get if we change the volume to 120. So we have a new volume. With this new volume, the question is, what would be the new mass? So we can easily understand that we have two separate situations. But there's something that links them. The link in here is that we're still talking about the same material. I'm not changing the material. That means the density is always going to be the same. The density is what links everything here. So that's what I'm going to try to find, the thing that links everything. So let's try finding density. Density is the link in here. How do you find density? The formula for density is mass divided by volume. So I'm just going to divide mass with volume. Okay. Now, which mass and which volume do I have from the same situation? The first one. I have the first mass and I have the first volume. The second situation is not going to work for me because I don't have the second mass. So I'm going to use the information of the first situation. The mass is 325 and the volume is 32. So I need to divide 325 with 32. That's going to give me the density of the material. And the density I'm going to get is 10.1563 kilograms per cubic meter. If I round and I leave 4 decimals, it's going to be that way. Okay. Now that I have the density, remember the material is not changing. That means the density is still the same for situation 1 and also for situation 2 is the same density. I can use it in the second situation. So how do we find mass? Because that's the question of the exercise. Mass 2 equals, to find mass, I multiply density with volume. So I'm going to multiply the density that is the same with the second volume, because that's the volume of the new situation, of the second situation. So I know that mass 2 is going to be equal to, density is 10.1563 times the volume, which is 120. If I multiply those things, the answer would be this mass. The answer would be 1,218 18.75 kilograms. That would be the new mass. How much mass would we have with 120 of volume? Well, 1218.75 kilograms. That's the mass we would have. Now let's go with exercise number 3. What volume of water has the same mass than 100 cubic meters of mercury? Okay, we're talking about water and volume. But then we talk about a different volume and a different material, which is mercury. So this is also a two situations exercise. We have two different situations, but there's something that is linking them, and is that the mass is the same for both of them. Same as in the previous one, the density was the same for both of them. So this is an exercise similar to the previous one. So what do we know? We don't know the volume, but we do know the water. There's something that we don't know here. So let's try writing the first thing that we know everything from. We know that the volume of mercury, so I could write Hg if I want, because Hg is the symbol that we use to represent mercury, Hg, yeah. The volume of mercury is equal to 100 cubic meters. Now, I know it's mercury. Mercury has a specific density because every material has a density, a different number of density. So the density of mercury equals what? I'm going to check which are the densities of each material. Mercury's is 13,600. So the density of mercury is 13,600 kilograms per cubic meter. Now that I have that, I'm going to write the information of the second situation. The second situation involves water. I know I'm talking about water. So water has also its own density. So density of water, which is H2O, right? Density of water equals 1,000 kilograms per cubic meter. You can take a look on the table and you're going to see that is the density. Density of water is 1,000 kilograms per cubic meter. So now that I have that, I'm going to write the question. What I'm trying to find is the volume of that specific water. So I'm looking for the volume of that H2O. I don't know the volume. But there is something that links both situations. What is linking both of them? That they have the same mass. So I can find the mass first because that's the link that's going to help me to connect both pieces of information. So how do you find mass? You find mass by multiplying density with volume. Now, which piece of information has both density and volume? The one of the mercury. I have density of the mercury and also volume of the mercury. So it's better to use that to find an answer. So I'm going to look forward to using density of mercury and volume of mercury. That's how I'm going to find the mass. So mass is going to be 13,600 times 100. If I multiply those numbers, the answer will be mass equals 1,360,000 kilograms. That is the mass. Now, what am I going to do with that mass? I'm going to use it to find the volume. Remember, the exercise is asking me to find the volume of water. So I need to use the formula to find volume. How do we find volume? Volume of H2O. Volume equals mass divided by density. Now, which density? Because we're talking about water, the density we're going to use is the density of water. Can we use this formula? Yes, because we have the density of water and also we have the mass, which we just find right now. So volume of H2O equals mass, which is 1,360,000, divided by the density of water, which is 1,000. If I divide that, it would give me the volume of water equals 1,360 square meters. And that will be the answer for this exercise. Now let's do another one. What is the density of a cube that has sides of 30 centimeters and a mass of 14.58 kilograms? Okay, in this case, they're not giving me the volume. What they're doing here is they're giving me a figure. It's a cube. If you remember geometry, a cube has this shape. The data says that that cube has sides of 30 centimeters. Now, we do not work with centimeters. We work with meters. So convert those 30 centimeters to meters. It's going to give you 0.3 meters. So the information of the exercise basically is telling me that each side measures 0.3 meters, 0.3 meters, and 0.3 meters. If you remember, there is a way to calculate the volume of a cube, which is area of the base, which will be this thing in here, area of the base. How do you find the base? Well, base times height, yeah. Times the height of the object, the height of the cube or the prism, which is 0.3. Basically, we need to multiply these three numbers, and that would give us the volume, because mass, meters, times meters is going to give me cubic meters, which is volume, right? So I'm going to multiply those things. So let's see, data. Each side is 0.3 meters. I know the object is a cube. What else? I know the mass equals 14.58 kilograms. And they're asking me to find the density. I'm trying to find density. Okay, so what will be the process? Remember that for density, the formula is mass divided by volume. Do we have volume? No, so we need to find it. Volume equals, in this case, not with the formula, because we're not going to do anything with this formula. It's not going to work because I don't know the density. I'm going to use a formula of geometry. The formula of geometry is basically area of the base times height. That's how you find the volume of a cube. So volume will be, in this case, 0.3 times 0.3. That will give me the area of the base. And then I need to multiply it with the height, which is 0.3 also. If I multiply 0.3 times 0.3 times 0.3, the answer will be 0.027 cubic meters. Now I got the volume. Now that I got the volume, all I need to do is use the formula for density. Remember, the exercise is asking me to find the density, not the volume. I need the volume to find the density. But the final answer has to be the density. So how do we find density? Mass divided by volume. So we're going to substitute the mass, which is 14.58, divided by the volume, which is 0.027. If I divide that, I will get that the density of the cube is 540 kilograms per cubic meter. And that will be the final answer for this exercise. With these 4 exercises, we can have an idea of how to work with the formulas of density, volume, and mass. And that will be it.